Hello everyone. So my name is Taavi, as you heard. Today I'm gonna tell you how to use Godot. I'm gonna teach you about the basics. But first I'll talk a little bit about myself because it's actually important here. Okay, so I'm a aspiring indie developer. I've developed a few small games. On the left there you will see AdSpace. That's the GameCamp game that I made last year. That was pretty fun. And on the right is another project I'm working on. It's unreleased. So about me, I study computer science at Talon University. And I am trying to finish up. So you need to make a thesis at the end of your university tenure. And my thesis is Estonian Godot learning materials. And as part of that, I am running this little workshop here where I will go through my own materials and then I will gather some feedback at the end. So I hope all goes well with that. Okay, so to the listeners, if possible, I'd like if you followed along with my work. I'm gonna do some Godot projects here, hopefully 2. And hands-on experience is just more effective than listening, in my experience. So, yep. And if you have any questions, write them in the chat here. I can see them. Okay, here's some important links. I'll be sharing those as we go on the Discord. Okay, so about the workshop. We're going to cover 2 major topics. Main concept of Godot, there's 3, and we're going to download it. That's going to be, a quick little segment. And then we're going to work on 2 projects. One's going to be like a Hello World type of thing, and another one is going to be a shooter platformer where we're going to delve into the physics engine and whatnot, sprites. Okay, so here I have a crude diagram or graph of the main 3 concepts. So the main 3 concepts are nodes, scenes, and signals. So a node in Godot is just an object with a purpose, pretty much. So here in this scene, we have a node 2D, a sprite 2D, a label, and a button. Those are all separate nodes. So a sprite 2D's purpose is, to display textures, images, whatever. A label displays text. A button is, a button. And all of these can be packed into one scene. And you can use a scene in another scene. So, it gets unpacked into those nodes. So it works in this sort of scene tree system. And And nodes also have signals that they emit when some significant event happens. So for example, if you click on a button, it emits the signal pressed, as I've written here. And other nodes can react to those signals, if you connect the signal to a function in a script. I'm sure all this rambling will make more sense later on. So, yeah, let's get to work, I suppose. Okay, so we're gonna open up a new browser tab. We're gonna go to godotengine.org/download. It should present for you, whatever your operating system is, the appropriate Godot version. Just recently, 4.4 came out a couple of weeks ago. I'm not the most familiar with it either yet, but we will be using 4.4. So in the middle here, you can just click on the button and it will start downloading a zip file. Then I'm going to open up my downloads here because I already downloaded this. So I'm going to look into the zip file here. I'm going to extract those files. And if you extract them, you'll find 2 executable files. On Windows, they're exes. I don't know what they're on Mac, and on Linux, they most likely don't have a file extension. Okay, so there's just a normal exe and a console exe. The console one also shows you like error messages and output from the engine if you would like to see them in a separate window. So you can just open up either one. It doesn't matter. Okay. Then I opened up the project manager here. I have a ton of projects. You may not have a ton of projects. Okay, so actually first, let's look at the project manager. Sure, why not? So here you have two tabs, you know, the one for your projects, that one for your asset library. If you were, you know, aspiring to make a certain kind of project here, maybe you can find one in that genre. You know, there's like a chess project here, and FPS multiplayer template, whatnot. But you know, we're not gonna look into those right now. We're gonna make our own little thing to actually learn about the basics, the concepts. So I will make a new project here. I'm gonna call it Hello World. The project manager is automatically gonna like create a folder for it, so I can just click create here after typing in the name. I'll take a second, I'll load up. Okay, here we are. So now we are in Godot. So let's press, actually no, wait. We have to learn about the editor first, right? My bad. Okay, so the editor, you can divide it into like 6 bigger parts here. So there's the like top bar here. I think you can call it the toolbar, you know, with the scene project, all these funny buttons. It's, you know, the top bar, quite slim. Then there's the scene dock here. It also has the import tab here. Here you can build your scene. Then under that is the file system dock. That's going to have all sorts of your project files. Currently we have Godot's icon here because, oh, I can't drag it here. That's Godot's icon. Then we have the main view that I just instantiated the icon into. The main view is, you know, it's going to display your scene. So once you've built it up in the scene dock here, whatever you made is displayed in the main view. Then on the right here, you have the inspector dock, and there's also the node tab and the history tab. From the history tab, you can undo your mistakes or whatever you made. We're going to learn about all that fun stuff. And then at the very bottom here, another thin bar. I think that's called the modules bar, or you can just call it the bottom bar. I'm going to probably use both terms. Okay, so let's do what I did earlier now, and let's make a 2D scene from the scene dock. So just click on the 2D scene button here. And our first goal is to just print a statement into the output that says hello world. So actually, let's drag our icon here, because then we have some sort of visual. And then we need to make a script that's attached to this root node, this sprite 2D node here. So we can do that from the scroll button here. That's with the plus. It's quite tiny. So just click create there. No need to change any settings. Just make sure that you have the template. So about this script. The very first line says extend sprite2d. Sprite2d is the node that the icon is here. So this here is a sprite2d. We're going to switch back to the script that from the toolbar. Okay, then we have comments here. Comments are started with a hashtag sign or a pound sign, you might call it. Then functions are declared with the func keyword. The name of the function here is ready with an underscore. You also need these parentheses. You can put the any function parameters into these parentheses. For example, the process one under here has a delta inside of it. Then after that, you have the return type of the function. The ready function doesn't return anything, so that's that. Then there's the pass keyword here, which is pretty much just a reminder, or if you use Python, sometimes you just use the pass keyword, and then it won't do anything, but it's just there, so the function exists. You can create interfaces and stuff like that with that. Okay, so I'll talk about the purposes of these functions. So the ready function is called when, this node is ready, when it's instantiated into the scene. And all of its child nodes also have a ready function, and then when those child nodes are ready, then the parent node is ready. And then the process function pretty much repeats itself every frame. So if you play any video games ever, they have this sort of frame system, FPS. So that's what this is. The process function renders frames, or it's called every frame rather. And the delta variable here is how many seconds have elapsed since the last process function call. So we wanted to print hello world. So we're gonna delete the pass here. Apparently people don't see the UI from the stream, so I had to scale it up a little bit. Forgive me. Oh, that's very large. Wow, that's quite impressive. Okay, let's change it a little bit. Let's put it to 150. Let's see about that. That's tolerable. Okay. Now we don't have a lot of room here, but that's okay. So we wanted to print hello world, so we're just gonna write print here because that's classic. So we're gonna write print hello world here. We're gonna go to the toolbar. We're gonna press run project here. This triangle sort of shape. You might know it from the YouTube logo. It's gonna tell you to select a main scene. You're gonna press select current because that's our main scene here. Now in Godot 4.4, they have this new sort of system where the game display is built into the editor. So this is quite new to me as well. But here you can see our icon that we dragged into the scene, and you can see that it says hello world here in the output that automatically opened when we ran the scene. So we're gonna stop that now. But what if we want actual text in the scene? The actual project to display some text. We're gonna use that label node that we talked about. So you can make a node, or you can make a label node. I pressed Control A there. That's a shortcut. But you can also do it from this a plus button in the scene dock. It says Add Child Node. So I wrote in label here, and it gave me the label. You click on the label here, you select it. You go to the Inspector tab. You can change various properties of the label. So the label here has a text property, which is the text that it displays. So we're going to type hello world in there. So now it's suspiciously overlaid with the icon, but you can go in the main view. You can drag it around. And what do you know? There it says hello world in quite small text. Now we can run the scene again. And hey, now it says hello world above the icon. So that's cute. But let's make something more functional. So let's make an user interface node here. The base node for all user interfaces is the control node. So as children of that control node, we're gonna add a label. Then we're gonna have a text edit, which is a node where you can input text into. If your script only shows extend sprite 2D, that's okay. You can also write those ready functions yourself. Just make sure you have the underscores, because yeah. But actually, that was something. I think they changed the default settings there, but I'm also going to add a button node to the text edit, and then I'm going to talk about that question. Okay, so I'm going to want to make a new script for this controller here. So you most likely did not have this template thing toggled. So the template is the thing that also wrote the ready and process function for me in there. Because some nodes have, common functionality, so you have a template for that. Now this node will not be called icon because it's not that anymore. Okay, so we're gonna call this control.gd. Okay, then we're gonna have to learn about variables and how to declare those. Okay, so we have various nodes here in the scene: label, text edit button, all that fun stuff. And we want to manipulate or manage those through this script here. So for that, we're going to need to write some variables. So we're going to call this variable label. But if we save this here with Control S, of course, then it won't show up in the inspector. So for it to show up in the inspector, we need to write the export annotation in front of it. Now, annotations start with the at symbol. So export here just exposes a variable to the inspector here. You can see that the label showed up now. And also, I forgot to mention that after the variable name here, I wrote colon label, which is declaring the type of the variable. So since it's a label node, it's a variable of the label class. Okay, so this is now exported. We're going to make another one for the text edit. Okay, and when we save, that will also show up in the inspector here. Now we can click on the assign button here in the inspector. We can select what node we want to assign to that. And then we can start manipulating them. We can write in the ready function here, label.text equals hello world with a spelling error. And then I believe we can just run this again, yes. And now it says our broken hello world there. Okay. But the purpose of this scene here is actually that you write into the text edit who you want to say hello to, then you're going to press the button, and then the label is going to say hello, whatever, GameCamp. But to do that, we're going to have to learn a little bit about Godot's UI system. So this little rectangle, I don't know how visible it is on the stream really, but this little blue, green, whatever rectangle, that represents the Zeiser game window. So I click on the root node control here. It's the entire size of the game window, but the UI nodes are positioned relatively to the game window in an anchor system. So we're gonna select the label node here. Then we're gonna, in the main view, there's this circular button with a cross. There you can select presets for these UI nodes for their positioning. I'm gonna click the center button here. And I'll write some example text in this so it's actually visible. Okay. Then it's it's here. Then we're gonna want to do the same thing for the text edit, but we are gonna want to make that preset bottom wide, so it takes up the bottom of our game window. But you can see that it's not really visible there. How do we change that? Well, we're gonna have to scroll down in the inspector here, or at least I have to since I'm very zoomed in now. We're gonna have to go here under layout. We're gonna click that. We're gonna find the anchor preset. That we're gonna click on this. We're gonna go up to custom, which exposes these different variables for the UI positioning. So we're gonna change the top value here to an even larger negative number. So I'm gonna set it to -81 because why not? Then I'll scroll up here and write in the placeholder text, who do you want to greet? Because that's just pretty. And then I'm gonna also position the button node here. Now the button node is gonna go center right. Now you may have noticed that, well, actually let me write some text in the button node here. So I'm gonna write greet, because this button is for greeting. So you may have noticed that it already is like in the appropriate place. It's like it's in the bounding box or whatever of the text edit that we set up, because it's a child of the text edit. So it went to the center right of the text edits box, I suppose. Okay, then that's our scene set up visually. And then we want to learn about signals now, I believe. So we're gonna go to the inspector node or inspector dock. We're gonna switch to the node tab here. We're gonna see all the signals that this button has. So we talked about the press signal earlier. We're gonna double click on that or press connect down here. Either one is fine. A window is gonna open up where you can configure, the function that connects your signal. It's gonna be called onButtonPressed, and the script is gonna automatically have that now. Now we have this onButtonPressed.
Some people say it's a bit too fast. Go like stop at some point and like, did you get it? Have you done it? Do you have any problems? Lecter style.
Okay. Okay. So now we have this onButtonPressed function, which is, how the root node, the control node here, reacts to the press signal of the button. So we're gonna write in here that we want to make the label variables text equal to hello. Then I'm gonna write a space there, then plus to add this these strings together, this text together. Then I'm gonna take the text edit variable. I'm gonna take the text property of that. So hello plus text edit dot text, assigning that to label dot text. Then we're gonna press enter, make a new line again, and we're also gonna clear out the text edits text with this line. So making an empty string. So now, if we go and run our project here and rewrite something into the text edit that will, I don't know what to call it. It's gonna say hello GameCamp when I press on the greet button there. And that's how the signals and the nodes work. And they're all part of this scene that, well, it's saved as icon, but, at this point, it's a little different. So, Does anybody have any questions about this? In the chat or... Yes?
So now they're using Godot script. They're using Godot script here now.
Yeah, GD script is Godot's own programming language. You can also use C# if you're more familiar with that, but GD script is quite literally designed for Godot, so it may be more convenient to use that. But it's a preference thing. We're going to use GD script here. Other programming languages also have unofficial bindings, so you can use Python or Rust or whatever. But yeah, we will stick to GD script here. Because it also has a similar syntax to Python. It's quite a simple language, I would say. Okay, so I don't see any questions in the chat, so I think we will continue now. So I am gonna, since this Hello World project is now ready, I'm gonna go to the project button here. I'm gonna quit the project list, or you can just close the thing completely. Either option is fine, but you have to, open up the engine again later. Then we will create a new project. We will create that 2D platformer project now. I'm just going to call it, Mega Shooter, because that's just a great name. Then we will create that. And this project is a little different. We're not just going to make it out of UI nodes. This project has some assets. So while that opens up, I'm going to find the assets link. It's going to be a zip file. Can I copy that? Yes. Okay. I'm going to open it up. It's going to automatically download in Firefox. I'm going to open up Discord. I'm going to send it in the general chat here. Yes, that's sent now. So I hope everyone can download that. Okay. Then there's going to be two folders inside of this assets folder. One is for sounds. We're probably not going to be able to use those because those come up way later on in my materials. But there's sprites which are important to us. So we can just wow, okay. We can just transfer the sprites folder into the editor by just dragging it here into the file system doc like this. But you can also do it through your file manager, whatever. So now we have our sprites here. It's this nice little pixel art. Then as the very first thing, we're gonna make the player. So the player is gonna be a character body 2D, and we're gonna make a character body 2D here by pressing the other node button, or again Control A, or through here. We're gonna write in character body 2D. Now it's gonna have this error message here. It says that it needs a collision shape 2D. We're gonna deal with that later though. But first, actually, let's rename this character body 2D to player. You can rename it by selecting it, pressing F2, or just clicking on it when it's selected, or you can do it through the right-click menu here. So I'm gonna rename it to player. Okay, then I'm gonna add a animated sprite to the as its child node. Now the animated sprite 2D also has a warning here. It says it needs sprite frames for it to be, a sprite that's animated. So we need to go into the inspector And we need to make a new sprite frames resource by clicking on this like empty box here. Then it shows new sprite frames. You click on it. And then to edit the sprite frames, you can click on this again. Our player is going to have, I believe, 3 animations. So we can make new animations in this module that opened up from this button on the top left of the module. It's like a paper sheet with a plus on it. We're going to make 2 animations there. So we have 3 here. The default, the new animation, and the new animation 1. We're going to rename these new animations to run and to jump. Then we have to set up the animations, so something is actually displayed. So to add like animation frames to this animation, you're going to click on this add frames from a sprite sheet button, which is this like grid design button. Then you're going to go to your sprites folder here, click on tilemap.png. The editor here is going to open up. I'm going to zoom in a little bit. Now, I know this off the top of my head, that this sprite sheet has 10 frames horizontally and 6 vertically, and that there is a 1 pixel separation between them. So you can change all of those things from the menu on the right here. And then we were editing the defaults or the idle animation of our player. So we're gonna just make that this one where he's just kind of standing there. So we're gonna press the add 1 frames button, and that's our idle animation. So if we zoom in on this guy now, you're gonna see that he's quite blurry. That's not very nice. So we're gonna go to project here, project settings from the toolbar. That's gonna open up a new window. Then, what was it? Textures. Rendering textures. In this menu here, you're gonna change the default texture filter of canvas textures to nearest. And that should fix our problem. Yes, now our pixel art is nice and crisp, which is how we like it. Okay, so now we can make the other 2 animations. The same workflow as before, so I'm going to zoom in here again. So this was jump, so I'm going to select the one where our little character, our little blue bunny is in the air with his epic orange gun, I think, or red, I don't know. That's that animation. It's not very animated because it has 1 frame, but our running animation does actually have multiple frames. So let's go to that. We're going to select both of these. You can just do that by dragging along both of those. Press add 2 frames. Now if I go here in the animations frame section and I click on this place selected animation from start button, our little guy is going to be running. I think this animation is pretty slow, so I'm going to raise its animation speed from the thing on the left here. I'm going to put it to 10. And now he's going quite fast. But now we should get to that collision shape. So we're going to make a new collision shape 2D node for this. About collision shapes, Godot has a variety of physics-related nodes, right? And they all share this collision shapes system. So it's modular. Yeah. Okay, so collision shape 2D is gonna give a collision shape to this physics node, the character body 2D that we created. Okay, then we're gonna go to the inspector. We're gonna make it a shape from this button here again, where it says empty. We're gonna give it a rectangle shape, a new rectangle shape, 2D. It's quite big here, but you can click on this again. We're gonna set it to, I don't remember, 12? Let's make it 10. 10 looks right. And 10 and 14. Now, his feet are sticking out from the collision shape, so we're gonna have to change its position here to 1 on the Y there, so 1 pixel off. Then we can save this as player.tscn. Then we can make a script for the player. Make sure that you have the template again. Okay, so this. Okay, so the template here has lots of interesting things written in it related to physics code. So there's a bunch of constants. Constants are declared with the const keyword. Constants are just unchangeable variables, I suppose. So we have a speed here and we have a jump velocity. This uses the physics process function, which is called exactly 60 times per second, compared to the normal process function, which is called as often as possible, whenever the game renders. But physics process is always 60 times per second. So let's delve into this code here. So the first line in the physics process is if not is on floor. So is on floor function returns a Boolean value, if your character is touching the floor. So this means if the character is in the air. And if the character is in the air, then it gets gravity added to it here. Then, okay, you know what? I did this a different way in my materials. Okay, whatever. I'll just wing it. So I don't actually like this template. So I'm gonna make my own. We're gonna use the process function because that's what we learned about. But realistically, for physics bodies, you should use the physics process function. But here we're just gonna use process because that's what we know and that's easier for us right now. We're gonna write pass here because actually we need to set up a couple things first. We need to go to project settings from the toolbar once again. Then we're gonna go to the input map tab here, where we can create the actions. Now, if you played games, you might want to change your keybinds sometimes. You find the default control scheme kind of inconvenient, uncomfortable, or you want to use a controller. This is where you set all that up from. So we're gonna add a new action from this. We're gonna write an action name here. So we're gonna make move right. We're gonna press enter, that will add it. We're gonna make a move left, press enter, and that will add it. We're gonna make a jump. We're gonna make a shoot. Then these actions are now created, but we need to add keys that will trigger these actions. So you press the plus button next to the action name here. We're making move right here, so I'm gonna press the right arrow key, and then I'm gonna press OK here. Then for move left, left arrow key. For jump, I'm gonna use the Z key, and for shooting, I'm gonna use the X key. Okay, then we can use these actions to make our player move now. So for movement, character body 2D nodes use a velocity variable, which is the speed of the character body, with also a direction vector added to it. So velocity is important. Okay, so we're gonna write if input with a capital first letter there is action pressed. We're gonna press enter because Godot provides autocomplete for us. If input is action pressed, move left. How to make character not blurry? You made the character not blurry from project settings. Then in this general tab here, I wrote texture into the search bar. So texture, that showed me the rendering part here. I went to textures. Then under canvas textures, I set the default texture filter to nearest. Earlier it was linear, but now I set it to nearest, and that fixed the blurriness issue. I hope you got that. Okay, so our movement. So if input is action pressed, move left. We're gonna change velocity.x. We're gonna make it like minus 200. And we're gonna do the same thing for moving right. So if input is action pressed, move right. Velocity.x is set to positive 200. So here I set it to negative because we're moving left. For positive, we're moving right. And but just changing the velocity variable doesn't actually move the character. We also need to call the move and slide function at the end of that. And then if I now I run this current scene from this button here, well, it's quite tiny, but you can see our character in the top left there. And he's just moving around now on the top. But we don't want him to just be out of sight like that, so we're gonna add a camera 2D as a child node to that. That is gonna make it so we our player is always centered on the screen. So we're gonna change the camera zoom property to 4. So there's a quadruple zoom and we actually, see the character there. So there's our guy now. If we run the scene again. But if you noticed, if you ran the scene and you just press the key, and then you let go of it, then the character kept moving. To change that, we need to set velocity to 0 here first. So, well, it's not going to be visible now because we have a camera tracking us, but that fixes that problem. Okay, so let's make a speed export variable for this character. So we're gonna write export range, and we're gonna call it speed. We're gonna make it a float type of variable with a default value of like 200. But export range wants some arguments for it. So in here, we're gonna write 0, 500, and that's it. That makes it so in the inspector here, we have this numeric variable. It's constrained within this 0 to 500 range whenever we set it. Because, well, if your speed is negative, that's kind of weird. And we're also going to declare a direction variable, which is going to have a default value of 1. 1 meaning that the player will go right, -1 means that the player will go left, and 0 will mean that the player isn't moving at all. So now we're going to use those direction variables and the speed that we just made. We're going to delete that movement code that we just wrote, but we can leave movement slide here. So we're going to set direction here as the first thing. We're going to use the input.getAxis function. GetAxis pretty much compares the action strength of two actions. So our negative action here is move left, and our positive action is move right. Again, since left was -1 on the direction and +1 was right, then that's the explanation for GetAxis. And then we can just write velocity.x equals speed times direction. And that will make sure that if we aren't pressing any movement keys, then our character stops moving. And that is a much shorter movement script than we had before. Well, again, we have the camera here, so that's not going to be visible, but that's that. Next, we would like to add jumping to our character, but for that we need to make a ground for the player to stand on. So we're going to make a tile map layer. And now it's going to offer you tile map at first, but that's a deprecated node, so we're going to use tile map layer. And we're going to rename it to level, the same way we renamed the player. We're going to save this immediately. And we're going to go to the inspector. And we're going to set its tile set. We're going to make it a new tile set. And then if you open this tile set here and you go to the tile set module on the modules bar, then press this plus button here, and Atlas. Then we're going to select our tile map. I think we're going to press yes, but it's going to not know what the separation is. Okay, so we're going to select the tiles that we want for our level here. As you can see on the sprite sheet, everything is pretty much the same color as the sky here, which is this sort of like, I don't know, light beige or something. So we're going to select all... they're all automatically selected if you did the same process as me. Never mind. Then we're going to go to the inspector. Under physics layers here, we're going to add element. We can leave these like that. Then we go to the paint tab on the tile set module here. We're going to select the physics layer 0 property under there. And we're going to click on the tiles in this sprite sheet that we want to be ground tiles, which is going to give them the collision shape. So I want these ones. Oh, not that one, but that's okay. Okay, so those are our collidable level tiles. The rest are like sky and decoration tiles. So now, if you go to the tile map module, which is separate from tile set, and you select some tiles here that you want to paint in the scene, I can just do that now. And that's how we are going to make a level right now. But we're going to need to make a main scene now for our player and level to go into. So we are finally using the scenes, or reusing them rather. So we're gonna drag the level here, or you can press Control, Shift, and A, which is gonna bring up the, the scene instantiation menu here. This is new, apparently. New design on that. We're gonna rename this Node 2D to main, because it's our main scene. If we zoom in, you can see our player is here. We need to make him a pretty little level that he can frolic around in. He is a rabbit. That's what they do. So I'm gonna make a quick level. It's gonna be probably pretty ugly, but that's okay. And then I'm gonna add some sky things here, some clouds, make it beautiful, really. Oh, that's the wrong tile, that's a grass tile. And for painting your level, there's also different tools here. Now I'm gonna use the bucket tool to fill in this square that I made. And then I'm gonna press the run project, which is gonna ask again for me to select a main scene. Now our character is in this scene, and well, you can move him around. Well, he doesn't have any gravity because we didn't make that for him. But he moves around now, and you can see that he actually does move. It's just the same way that we wrote his code. So now we're gonna teach our character how to jump and how to feel gravity. That's a strange sentence to say, but I'm gonna make a new variable for the gravity. I'm gonna set the gravity to 25, which is pixels per second. All of these speed values and all the gravity is pixels per second. So if you set the velocity.x here to 200, I believe I set it to, then that is pixels per second. So the character is going to be able to move 200 pixels per second. Okay, so we are going to use if input is action just pressed. And we want that to use the jump action because we want to make our character jump. We're going to write velocity.y equals, we need a new variable for the jump force. We're going to make that pretty much similar. We're going to set its power to like 500. You can set it to whatever you want, but 500 is going to be quite visible on this screen. So velocity.y equals minus jump force. Minus jump force because on your in your game window, like down on your screen is like the positive y direction, and up is the negative y direction. So we want to make it jump, so we want to make him go in the negative y direction for a little bit. But if we run the main scene now and we press jump, our character is gonna kind of just blast off into space because we're not using the gravity yet. So if you think about it, gravity is like a constant force on the player, a constant force that's pushing him down, while the jump is a one-time force that eventually the gravity pushes against enough and then the player lands back down on the ground. So we're gonna write here under the velocity x line, we're gonna make a new line where we apply the gravity constantly. And now, if we run our scene, our little guy has a really high jump, but now he can fall, and now he can jump, and now he can move around. So that is great. Next, we need for our character to be able to shoot bullets because, well, we call their game Mega Shooter. We're gonna shoot some enemies. I don't know if we're gonna get to the enemies part where we are gonna try to shoot bullets out of our big epic gun. Okay, so the bullet is also gonna be of the character body 2D type. So make a character body 2D node here. The bullet isn't animated in the same way that the player was, so we are going to use a simple sprite 2D instead of an animated sprite 2D. But they are fairly similar in their workflow. But for sprite 2D, you just set its texture and you don't have to worry about animations. Although you can animate them as well, but we're not going to delve into that here. So we're gonna press on the empty here on the texture, and we're gonna make a new atlas texture, which is gonna let us crop out a part of our big tilemap.png that we have in the sprites folder. So we open that up. Then under atlas here we have to, now you can press quick load, which is going to show us the tilemap.png. Now it's loaded here, but we're going to need to select the exact bullet sprite here. I'm going to set snap mode to grid snap, and I'm going to do the same thing that we did earlier. The step between these tiles on the tile sheet or sprite sheet is 16 pixels, and they have a 1 pixel separation. And this is our bullet here, this little line. So now, since these sprites are very small, I need to zoom in constantly. I'm going to rename this character body 2D to bullet then. And then I will save that scene with Control S and Enter. And now we can make a collision shape again for the bullet here. We're gonna use a rectangle shape like before. We're gonna set its X value to, I'm not sure, 14, 12. Yes, 12 is pretty good. Then let's try 8. Let's try 6. Yes, okay. So the rectangle is 12 by 6 pixels large. Then I need to tell you guys about actually collision layers. I forgot to talk about that. Okay, so I went back to the player scene. We're gonna look in the inspector under the character body 2D section here. And we're going to open up collision, or no, we're going to go to collision object 2D and we're going to look at collision. You're going to see that the player's node here is on the first physics layer. Massive tooltip, thank you. So you can see that the player is on the first physics layer, and that its mask is also on the first physics layer, which means that it detects the ground, because our ground is on the first physics layer. So we're actually gonna set, okay, anyway, physics layers, fun stuff. I set it to layer 2 here. We can also change their names from the project settings here again. So we're gonna write in layer here, and then you scroll down a little bit to the physics section here under layer names. Layer 1 we're gonna call level. Layer 2 we're gonna call player. Layer 3 we're gonna call actually enemy. Although I believe we will not make it to enemies because we have time constraints. And layer 4 we'll call projectile, which is what our bullet is going to be. So now our player is on the player layer and it detects the level layer. The tile map that we created is on the level layer. And it detects itself, but it doesn't really need to. This doesn't matter. But that's whatever. Our bullet is gonna go on the fourth layer, projectile layer, because it's a projectile that our player shoots. And it's gonna detect only the level right now, because we are gonna make its hitbox a little bit differently. We're gonna use another node for that. But first, let's make it actually shootable. So let's make a new script, pullit.gd. I do not like that template, like we established. So I'm gonna make it a fairly similar structure to the player. It's gonna have a speed again. But our bullet does not have a gravity because, it flies in a straight line, it's a bullet. So we don't need to declare a gravity for it, but we do need to declare a direction for it. Which is, again, a float type variable. Then we're gonna make the ready function. We're gonna write pass here actually, because we need to declare an export variable for the sprite 2D that we added, because we want to flip the bullet depending on the direction that it's shot in. So we're gonna make an export variable called sprite here, which is of the type sprite 2D. And then in the ready function, we're gonna write sprite.fliph, and if the direction is less than 0, aka it's to the left, then the bullet needs to be flipped, because if you look here in the scene, well, it's not very visible, but if you look here in the scene, it's going to the right. So we flip it if it's going to the left, then the sprite will look correct. But then we need to make a process function again for actually moving the bullet. And the bullet's movement script is a little bit easier. It doesn't move according to the player input, it just moves. So we are just gonna set its velocity.x here to direction times speed. We're gonna write movement slide, but we want our bullet to disappear, once it hits a wall, right? So to do that, we need to check if it's in contact with a wall. If you remember from the template earlier, it had a is on floor function, which checks if the physics node is in contact with the floor. So there's also is on wall, which we're going to use for this bullet because the bullet flies in a straight line, so it can only fly against the wall. So I'm going to write if is on wall. And then if this node is in contact with the fall, I'm going to queue free. Queue free means that, well, free means that this node will get deleted, and queue free means that it's going to get queued for this, because freeing is, I believe, a sort of awkward operation for Godot, so it needs to be queued, or that's how the engine prefers it, rather. I don't really have a great explanation for that, but we will write queue free here, which will delete this bullet when it comes in contact with the wall then. But before we make this player shoot the bullet, we need to assign the sprite a value here in the inspector. And we're also going to set character body to these motion mode here to floating, which is going to report all of its collisions as wall collisions. You can also use motion mode floating when you're making like a top-down game, because then you don't have like gravity and stuff that matters like that. Okay. Then we are gonna go back to the player. Actually, did I set? Okay, yes, I set the collision layers. Make sure you have yours set. That's an error that I run into quite often. Just forget to do a little thing in the inspector. Okay, so our player wants to shoot this bullet. How are we gonna do that? Well, we know how to get the input thing going. If input is action just pressed, and now we write in shoot here. But what are we gonna do now? Well, now we're gonna use signals again. We're gonna make our own signal called shot projectile. You make your own signal with the signal keyword and then the name of your signal. With this signal, we're also gonna pass along a position, which is going to be of the vector2 type, because it's a vector in 2D space, and a direction, which is also going to be, no, a direction is going to be float, right, because our directions are floats. Now our player needs to emit this shot projectile signal to the main scene. It's going to do that. So how do we make it emit this signal? We're going to write shot projectile dot emit, and then in the parentheses here, we're going to write the two arguments that we have. So we're going to write in global position because positions are relative to their parent node. So, okay, well, in this case, actually, it doesn't matter, but the player has its own position, the animated sprite has its own position, all of these nodes have their own positions, and they're all relative to their parent nodes. So if I move the camera's position here to, like, I don't know, 10 pixels, then it's always going to be in front of it. But if I ask the camera for its position, it's going to tell me 10, even though in the grand scheme of things, it's actually not at x10. So to know its like actual global position in the grand scheme of things, like I said, then we need to use the global position. So we're going to emit the global position, and we're going to emit the player's direction. Yeah. Then we're going to go to the main scene again. Now the main scene is going to need a script. So we're going to make a main.gd. Main.gd is going to have not much in it actually. But now we go to the player that we created here. We're going to go to its signals, next to the inspector tab. There's the node tab. We're going to click on node there. Shot projectile here. We're going to connect the player's shot projectile signal to the main scene now. Now it's connected to its script. Then we need to instantiate a bullet. For that, we are going to load the bullet's scene in, so to say. So I'm going to make a new constant called bullet scene in capital letters, because that's sort of the standard for constants in GD script. Now our scenes are saved as a packed scene, or in the editor, there's the packed scene type for them. And we're going to use the preload function, and we're going to write our bullet scenes path into it. So this line. So preload is going to make it so the scene gets loaded as the main scene is instantiated. And this is the path of our bullets scene here. They are saved with tscn file extensions. So now we can instantiate our bullet. So we're going to write var bullet, because we're going to make it a local variable of this function here. We're going to write bullet scene dot instantiate. And now for this bullet, we need to set its global position to the position that it receives from this function. And also its direction, same way. And then we are going to add it as a child of this scene. So we're going to add child bullet. And now, if we run this scene, our player should be able to shoot. Our player doesn't rotate along with the bullets, but I can shoot them now. Now, if I'm not moving and I press the shooting button, they don't move along with me. So we are gonna fix that by going to the player script. I'm gonna close the output module here to see more of the script. We're gonna make a new, we're gonna change the way we deal with the direction a little bit. We're gonna make a new variable for direction input, which we are gonna set to 1.0 again. And then instead of setting direction here, we set direction input to get access, because if you think about it, direction shouldn't be able to be 0. So that's what we're trying to fix here, because when our direction was 0, the bullet's direction was also 0, and since our velocity is speed multiplied by direction, you multiply something with 0, your answer is 0. So that's why our bullets were not moving. Okay, so now we need to actually get the direction here. So if direction input is not 0, then direction is going to be sine f of direction input. Okay, so what these two lines mean. Okay, so direction input, since it can be between -1 and 1, and it can also be 0, which we didn't like, we make sure that direction input isn't 0, and when it's not 0, we set our actual direction to sine f of the direction input. What is sine f? Sine f, well, just takes the, I suppose, sign of the variable, of the number. So if our direction input is a positive value, then it's going to be 1. If it's a negative value, it's going to be 0. Or no, it's going to be -1, my mistake. And if direction input was 0, which is a case that we just eliminated here with the if statement, then our direction would be 0, but it's not. So that should fix our little bug here. But we need to change things around a little bit. While the bullet needs to know our accurate actual direction, our velocity.x calculation needs to use direction input to make sure that we, aren't in constant motion like before. And now, if I move left, I shoot bullets to the left. If I move right, I move bullets to the right. If I'm not in movement, it doesn't matter, because I still shoot to the direction that I'm actually facing. But let's make our player also face in the, actual direction that it's moving in. So let's make a new export variable for its animated sprite. So we're going to call it animated underscore sprite. It's of the animated sprite type. And we're going to go to the inspector again. We're going to make sure the player root node is selected there. And we're going to press animated sprite. We're going to assign that. And now, since we have an accurate direction here, we're just going to animated sprite dot flip h. Same way we did it with the bullet. If the direction is less than 0, aka it's to the left, then the character faces left. And yay, now he does that. But we also made animations. Let's set those up real quick as well. But let's make a new function for animation. We're going to call it animate sprite. And let's check what animations we had. Okay, there's one for just standing around. That's called default. There's one for jumping. There's one for running. Okay, so I want to close this. There we go. Okay, so we have a default, we have a run, and we have a jump. Okay, so let's think about the logic here. So if our player is not on the floor, aka our player is in midair, then the player is probably jumping. So we're gonna make the animated sprite play the jump animation. Okay, then if direction input is not 0, or we're gonna make an elif, which is else if, but it's just Godot style. So elif direction input is not 0, then we're gonna play the run animation, because that means that we have direction input. That means our character is moving around. And At the end of this, we're gonna write an else statement, animated sprite, dot play, default, because if our player is not jumping or running, then it's probably just idle. So we're gonna play the default animation. And now if we run the script, oh wait, I forgot to call the function. We have the animate sprite function, but we need to call it in the process here. It doesn't run automatically. So I'm gonna do it before movement slide here. Now I'm gonna run the project. Yeah, our character runs around, our character jumps, our character shoots fairly slow moving bullets. Okay. So we have about 6 minutes left. So are there any questions about this again? What we made currently with the physics nodes, as much as we managed.
Is it possible to ask data general questions?
Sure. You can ask right now.
With really specific, I'm curious about using videos of your games. How is it to use videos, that multimedia?
I believe there is a video player node that you can just, I'm assuming, put like your MP4 file or whatever into. I haven't used that myself, but I do believe there is that functionality because you also need to have the capability to play audio, and it's a similar system if you think about it.
Is there some virtual production elements or
What?
virtual production elements like in Unreal Engine you can make some? Make an extra video like an edition, etc. Is it too specific?
I don't think so. I mean, there's shaders, but those are a little complex for just like editing your video or like, well, you can apply like a filter with that, with shaders. But I would say no. Although this is not my area of expertise, so I may be wrong. Anyway, I'm not seeing any new questions in the chat, so since we are kind of coming up on the final few minutes here, I'm gonna share the feedback form because I would like some feedback for this workshop. So it's a little Google form. I believe there were 10 questions, so it takes only really a couple minutes to answer. So I would love to get a couple answers. If you are interested in a not as improvised Estonian Godot material, then you will be able to provide your Discord username in the quiz. And then I will contact you, and then you can go through them and help me with my thesis, because I would really like that. And from the current feedback of my Godot materials, they were written quite well, so perhaps that is a better format than me speaking. But I hope everyone was able to learn a couple things about Godot here today, about its node system, about the signals, maybe even a little bit about the scripting. But yeah, we are kind of running out of time here. So, is there anything else I could do real quick?
So links are page links.
I sent it to the Discord, but here you go.
one question. Uh, just to understand the limitations or complexity. If I want to play the same game, but the input is, let's say, voice command, is it the extra complexity to implement in Godot environment? Just what I want to use voice to jump, for example.
Mm,
How
I mean, I'm sure that's possible. I personally, again, I haven't done anything where you need to like use your microphone input for that, but I imagine that's totally possible because I don't see why not. I believe there's some issues with like using your webcam, but again, I've stuck to basic like 2D games, like I showed earlier. There's a little game with the robot and the little puppy and the war tank machine. That's one of my bigger projects. But yeah, I guess that's all for me. So yeah, thank you everyone.